Hey there, welcome to Beyond Fee. Construct 3D model from multiple images with Google Colab. So in this video, I'm gonna show you how to construct 3D model with multiple images without any prior camera parameters needed. So let's go into the topic. So I shared this paper. This is the paper released by Industrial by Naver Labs in 2024. As you could see in the architecture, the unconstrained image passed to Destrier framework, which construct the whole framework to produce the 3D model with multiple images without any camera calibration needed. And then it produces it calibrates, then it estimates the depth, then finds the pixel coordinates and camera pose estimations. With these, it constructs the 3D scene or 3D model. And the mainly it will come with the structure SVM, and yeah, I'll share the paper in the content or the blog. You could check it further. Going further for the implementation, you could see here is the repository for Destrier implementation, and here we're gonna implement everything in Google Colab using the GPU. So let's go further as we see this architecture before. And going further, let's create a collab collab notebook. So I'm gonna give a new notebook. Yeah, perfect. So I'm gonna change it to sample 3D construction tutorial. Tutorial 1, let's say. Now I need to change my runtime to GPU. Now I'm gonna save it. Unable to connect the runtime. Okay. So it's being connecting as you could see here. Yeah, perfect. It's now connected. Now let's go for cloning the repository here. Let's paste here and run the repository. It's being run well. And now, so next thing is changing the directory, which is not gonna work in Colab. And then we gonna go directly. So here you could see they have like the instructions for creating in local, but now as we are using Google Colab, let's go directly to the installation. Oops. So now I'm gonna paste here. Every time you need exclamatory to run the commands in notebook. So let's go here on the requirements. Let's copy the path and then paste on the requirements. Now you run the code, run the command. It's installing as you could see here. Let's delete this. Yeah. So it's keep running. So this is the easiest way I find for people who are not affordable for the resource, but the efficient way and the optimal way for running the 3D, generating a 3D model from multiple images quickly. And it's keep installing. Let's see. So this is the most waiting part for every programmers, that the installation part. So let's keep waiting. Yeah. So but also note that every time you need to run, you need to change the runtime to GPU. So Dust3R framework entirely works on only CUDA. So CUDA disabled is not gonna work. So make sure wherever you run, the CUDA is enabled. In next video, I can show you how to run on the local using the GPU. So now the packages are being installed. Let's see. the execution have been completed. And next thing will be to run the demo. So go here, copy this, and paste it again. Let's go run. Oops. So it says that it can't open the file. As I said, the project working directory is on the contents. So we need to copy the demo.py path, the local path, and then paste here. Let's paste it and we're gonna run it. Things are being generated. It opens in UI. Let's see. Okay, something is being installed. I think this is the model that have been installed. 57 percentage, 74, 80. Okay, let's go. Oops. So it says it's hard to connect. Let's see. So it says set share equal to true to launch. Let's try some things. So I guess I have stopped because the path given is on the local path in which we can't open on the local with the Google Colab. So there is another thing that in which you can make it public. So the thing is PyNorm, in which I will share the whole notebook to you. In pip install pyngrok. So you're gonna install this. Let's install this, and we're gonna find the public URL. So basically we need to make it public, and let's look at the IP. For example, here I gonna paste it. Just take the port. So you import ngrok, and then you connect the ngrok, and we're gonna print the public URL. So let's run this. So it says there is a error. Let's go. Application failed. Usage of ngrok requires a verified account authentication. Oh my. Let's need to look at another methodology then. Oh, sorry for that. I think we need some authentications and create the account and blah blah blah, some formalities. So I think we could skip this because there is another way. I think that could make life easier. So let's delete this and delete this as well. So directly go to this, and so as I said, like this is the command to run it, but there will be just go into the demo.py, and inside you can see the whole code that could execute the whole uh, let's say the framework to construct. Inside the dust3r, the repository, you could see another dust3r, in which if you go inside, and again you should see demo.py. Let's go into that demo.py, So here you are, and you need to go down where launch dot. Yeah, so demo.launch you can see on the end and make that as true, in which making this true will launch the your application public. So let's make it true, and then now let's save it, then let's run this. So I'm gonna run it. It's running. Let's see. So the framework is running. It's taking a bit time. Wow. Now it's the Gradio is on live. So let's open this. Open a new tab. So it's loading. And I guess you can see the log of everything running on this thing. Wow. Now it's there. Let's go. So here, as you could see, there is on the top container, it have like upload the file here, and then it says the global alignment is linear and the number of iterations we want and all possible image pairs. Also, we have like the parameters that need to be set. So what I say is just transparent cameras. So let's give these. So as of now, I just give the point cloud cleanup depth and transparent cameras. And to ensure the images, I have some sample images of a object. So here you could see I have downloaded some sample images of the pot where you can see the pot. Let's make it large. Yeah, so you can see the pots taken in different angle. Actually, I could share the link for this dataset in the description, so you could have access also for the sample datasets. So let's upload these. So I'm gonna click upload. Yeah, and then I'm gonna select those images on the folder that's there. As I showed you in the folder, I'm gonna upload that. Yeah, now the images are being uploaded. The upload, it says it is uploading 16 files. Let's wait for that. Once it uploaded, let's check. So thank you for waiting, and it's been uploaded. Every images is being uploaded. Now let's run the iterations. So also let's adjust the global alignment, but let's now test it with 300, changing nothing, but just adding the things that need to be displayed. So now I'm gonna run it. I'm gonna click run. So things are running. Now things are being displayed on the log that you have been running on the Google Colab. So you could see things are being running on the log of Google Colab. You could check here. You can see the global alignment was done and the parameters have been generated. So you could see the edge values, and on the down on the last before you can see the poses, in-depth maps in poses in focals were generating. So let's see how it gives. Now you can see everything is generated, and let's go to the UI. Boom. Here you go. Now the 3D model has been generated, and you can see all those the camera. pose, and the position and orientation of the camera has been visualized the simulation. And here is your model, not bad actually, because you can see the point cloud. So the point cloud is being plotted, and going further, you can see the depth maps. So this is the depth maps being generated. So basically, monocular depth map is generated, and everything is merged, and main features have been generated, the calibration details, the eccentric and eccentric parameters. Also, once you have the model, there is a option to download here on the top. So now you can download and visualize in your 3D viewer. So thank you for watching. Stay tuned for the next video, and please comment us if you have any suggestions that we could add add upon on the 3D computer vision world, or the videos on uh, computer vision applications. So this could be used on the applications of industrial inspections or manufacturings or even automotives. And also we are working on the space applications for the proof of concepts and space scavengers, something like that. So let me know in comments if you have like specific feedbacks. I would welcome it. Thank you for watching.